So, we studied the IP protocol in the last class and the design of the IP, the internet protocol. What are the different sections of the modules like the routing module, the reassembly module, the fragmentation module, how they help the IP or the internet protocol in the TCP IP suite to travel from the source to the destination. This is whatever we studied is about the host to host communication or the network layer communication when the routing takes place from the source to the destination. Now, coming to the other part, let us say the sender is in one network and the receiver is in another network or even in the same network as well. When it travels, the datagram travels from the source and it has been forwarded by several other hops. When it reaches to the destination router, the final router, now the router has to decide if the host is available in my network, then who is the actual host to whom I should deliver the datagram. That means you have a two layer addressing, one is your network layer addressing and another is your physical layer addressing or the physical addressing you can say. So, in this network layer addressing, your IP address finds in the whole globe of the internet you say the source network and the destination network. If this is the source network and this is the destination network, the traveling from the source network to the destination takes place via any of the number of routers and it reaches to the destination network. This is your routing part and this is taken care of by your internet protocol, who finds which is the destination network where my destination node is available. So, now it reaches to this destination network or you can say the router here, the gateway here. Now, this gateway will decide in this network, my network, where is the actual receiver to whom the packet has to be delivered. And when the datagram travels, if you remember the header of the datagram, there was a field, the source IP address and the destination IP address, right. One is the source IP address and another was the receiver IP address or the destination IP address you can say. There are two fields. So, when the source IP address is the originator of the datagram, if the SIP is the originator of the datagram, this destination is the final destination of the datagram. Here is the final destination. Now, in between several routers they have to take care of the datagram, like they receive the datagram, they store it for a while, they find the next hop, they forward it through the next hop. So, these are the different processes that has been taken care of and we have seen that throughout the IP designing and the IP protocol, the header information and all those. Now, coming to the next part, now we are talking about the receiver network. If this is the destination network, how a datagram that comes to the destination network is delivered to a particular receiver, and this is decided by the destination IP address of the network, destination IP address of the your data header field of the datagram. So, to identify a host in a network, as we discussed once in the class, any node can have the identification, two layer identification. One is the logical identification and another is the physical identification. This is logical because it is generated by a software. This is physical because this is given by the manufacturer, right. This can change if the software programs in a different way. This cannot be changed unless you change the NIC of the host. That means the file, the physical address or what we say is actually the MAC address. This changes only when you change the NIC, or even sometimes you take the host in another network, then the IP also changes. So, there are different cases of changing of any of these two addresses. But when these two are combinedly assigned to one network, one host, or we say the logical IP, the logical address you can say, the logical address is mapped to the physical address or vice versa. So, for this mapping, that means for a particular logical address, the physical address has to be defined, and for a particular physical address the logical address has to be associated with that. So, this mapping of the logical and the physical can be done in two ways. One is the statical way, another is the dynamically. When it is a static mapping, it is very easy, you know that. Every host in a network, any node in a host, any host in the network will have a table with a set of logical addresses and corresponding physical addresses. So, what happens when a host has to forward a packet, it checks for the destination IP address, sorts the destination IP address in the mapping table, and the corresponding physical address is searched and it sends. A normal or a simple static mapping case of logical to physical address, or the even the other way also is true, that means from the physical to the logical address. But again, as I said, this is not reliable. The reason is that if the node changes its NIC, the MAC address changes. So, this mapping does not remain valid. Other way, if the software changes the IP address, the logical address, then again this remains invalid. So, you need again another constant updation of this mapping table to find out what is the updated physical and the logical address status. So, two problems associated with the static mapping is, one is the storage space. Obviously, every node having in the internet, if you decide every node having a table saying that this is a logical address and corresponding physical address is this, consumes lot of storage space. And the second one is the constant updation of the table. So, you need again another algorithm, something to update it regularly, consuming the computation time, all the resources. So, we say this static mapping of the addresses, the logical and the physical, are no more a wise option. So, you can think of another option, which is a dynamic mapping of the logical address versus the physical address. So, what happens in this, when a logical address is given, a certain protocol is executed and this protocol gives us the physical address, and this protocol is called the Address Resolution Protocol or ARP. In short, we say this is ARP. And the reverse is true, when your physical address is given and the corresponding logical address will be mapped, that is called your reverse ARP or RARP. So, we say IP is associated with several sister protocols, and they are the one of them, they are the ARP, RARP, and few more are there, we will discuss them later. So, these two protocols again designed to map dynamically the physical address and the logical address and gives the host the corresponding required address by executing this protocol. So, we will study about the ARP protocol first, and we will see how this executes, the ARP or the Address Resolution Protocol. So, we will see the format of the ARP format, how it works. Again, it has got 32 byte words, as in case of your IP datagram. They are all 32 bit words or 4 byte words, you can say. The first one is having two fields of 16 bits each. The first field is called the hardware type, the second field being the protocol type, you can say. What the hardware type says, like every LAN in the globe has got an unique ID, and that is your hardware type. What is the kind of network? That means if I say Ethernet, if my LAN is a Ethernet LAN, let us say the number is something 101 or 5, so that will be indicated here. That means the ARP, the protocol is implemented or working on a network which is an Ethernet network of number 101. That is what is your hardware type, saying that this is an Ethernet network. Coming to the next one, the protocol type. This says again the kind of IP you are using. Usually what we do is the IPv4. So, in that case it gives a number, IPv4 has got a number and that number will be indicated here. That means the internet protocol we are using is IP version 4 and the hardware protocol we are using or the network protocol, file layer protocol we are using is the Ethernet. Those two are specified in these two fields, the hardware type and the protocol type. Coming to the next word, again the next word is divided into 3 fields. The first one is divided again into 2 fields of 8 bits each. One is the hardware length, another is the protocol length, and the next one is the operation, kind of operation is that is being done here. Let us say you have an Ethernet. I say that my LAN type or the hardware type is Ethernet. What is the length of any Ethernet address or the MAC? Ethernet means it is a physical address, right. So, what is the length of the MAC address or the physical address? 6 bytes. So, this is denoted here. The length of the hardware address is the or the kind of address that is being used by this hardware is the MAC address, what we say, and of 6 byte length. Similarly, for the protocol length, if you say it is IPv4, what is the length of the IP address? 4 bytes, right, 32 bit 4 bytes. So, that is mentioned in the protocol length. So, the type of the network and length of its address scheme are being expressed in this header fields. And coming to the operation part, because it is a mapping of one address to the another address, this is kind of a question and the answers or the request and the reply kind of thing. So, one request, the other one replies back. So, 2 operations are possible here, one is the request operation and another is the reply operation. They have the different identification and they are mentioned by this operations field. These two are the major fields of the header. Other than that, you have the sender hardware address. These are very important field. You need to remember which field has to be filled when it is a request or when it is a reply message. The sender hardware address, which is again a 32 bit word. Then you have the sender protocol address. When I say hardware address means it is the MAC address of the sender and this is the IP address of the sender, right. Sender means the source who generates the datagram. Then you have the target hardware address and another is the target protocol address. So, this is again the receiver MAC address and this is again the receiver IP address. Now, consider this is a request operation. Let us say the header is or this format stands for a request operation. That means the sender is requesting for to know the physical address of the receiver. Receiver, when I am saying the receiver, it is the ultimate receiver, the final destination. So, in that case, which fields of this header will be filled? Can this sender hardware address will be filled? Can the sender fill its own MAC address here? Yes, because he knows his own MAC address, so he can fill this when it is a request. Can he fill the protocol address, his own IP address? He can. This is filled. Can he fill the target hardware address if it is an ARP? Can he? No. So, this is a question mark or this field remains blank. Can he fill the target protocol address, the target IP address? So, when it comes to a request, only this field remains blank because the sender knows what is the IP address of the receiver to whom I am sending the datagram, but he does not know what is his hardware address, right. So, what happens here now, this ARP request when generated with this format will be broadcasted in its all the outgoing path of the source or the sender, and everybody in the receiver section will receive the same ARP request. But the intended receiver or the router who knows that the host is in my network or who can be even the final destination only send back the reply. So, when this is a broadcast message, request is a broadcast message, reply becomes unicast, because when the receiver sends the reply, it fills the field, the target hardware address, and sends back this as a reply, changing the operation to the reply mode and sending with the sender MAC address and sender IP address are known in the header. So, it can directly unicast the reply packet to the sender. That is how your ARP request and ARP reply are exchanged between the sender and the receiver. Now, when I am saying about the receiver, there are multiple receivers, there are multiple cases even, right. So, before going to the multiple cases, we will see how exactly this is. Now, your datagram is ready, or your ARP request or ARP reply, anything is being now ready with its all the header informations. So, now next what? It has to go to the next layer, the lower layer, that is the data link layer, and it has to be encapsulated into the datagram has to be encapsulated into a frame. So, now next is your encapsulation of the reply or the request into the frame. And you know what is the frame format, right? Usually what is the frame format? You have a preamble, or you say the delimiters, then you have a destination address, yeah, there is another source address, maybe you can swap this destination address, source address, and there is a field called the type field. This type field says whether it is a ARP or this is an RARP or any other control message. What kind of frame it is? If you remember the supervisory frame, the control frame, the unnumbered frame, right. So, information frame carries the information, the data. The supervisory frame has some control informations. So, one of the field of that says what kind of frame is it? This is an ARP frame, and this ARP frame will be indicated by the type field, and in the data field of this frame you will have either the ARP request or the ARP reply, depends. It could be ARP request or it could be ARP reply, right. And again you have all those CRC, the end limiter, all those things, checksum, everything. We do not bother for that, that is all the frame structure part. So, now this indicates that you have a ARP packet, and this ARP packet is again whether it is a reply or a request indicated in the frame, and now it is transmitted from the sender side. If we consider this as a sender, the datagram has to be, what is the ultimate goal? Sender, what is the ultimate goal of the sender? The datagram has to be, or the packet, let me talk about packet, convenient for me. So, packet has to travel, it has to be generated, it has to travel, it has to be delivered to the destination. Now, before the delivery of the packet, the destination has to be identified. Unless the destination is identified, to whom the datagram will be transmitted, right. So, to identify this destination, you have the ARP that actually precedes the datagram. That means, if this is the sender has generated the packet, it first sends an request for ARP indicating where is the destination. Wherever will be the destination, we do not bother, maybe in the same network, maybe in another side of the globe even, but the destination has to send back the reply, ARP reply. When it sends the ARP reply, then your packet follows the path and packet is delivered to that host. That is how your delivery of the datagram takes place.
So, what is stored in the destination address of the frame?
Which one?
Destination address of the frame, what is stored?
Tell me, you tell me.
It is broadcasted initially, so that
This address, right? It is a frame. Frame means, I think probably we discussed this thing earlier. This is a source and this is a destination, right. Now, the let us say this is a router, intermediate router. The source has to make a frame and the frame has to be transmitted to the receiver, but this is not the final receiver. So, what will be the destination address then? The intermediate one. It comes here, it is decapsulated again, it goes to the upper layer, network layer, again encapsulated, again becomes another frame, then again it goes. So, this destination address we do not bother. What we bother is this destination address, this destination target, this address, because this is the final address of the receiver. So, intermediate frames, whatever destination address they put into the frame is all the intermediate frames, because that is point to point communication, but this is not point to point communication, this has to be delivered at the other side of the goal, right. So, what happens here? Now, let us consider different cases. Consider a single network, your source is here, your final when I am saying the destination, it is the final destination. Now, the datagram is generated here, your datagram is generated here with your IP address, SIP and DIP, source IP and destination IP. Now, when the ARP goes or the ARP is executed, what is the job of the ARP? It has to map the IP address with the corresponding MAC address, the physical address, right. So, which IP address it should map is the IP address of the actual datagram or the packet, because the host is in the same network. So, the address that will be mapped is the IP of the packet that will be mapped to the hardware address of the destination or the MAC address of the destination, because it is not going to the outside the network. Now, consider a case, here is the source, here is the intermediate router, here is the destination, this is the router. So, when the source generates the packet with its own field SIP and DIP, ignore the other part, the source IP address and the destination IP address. When the datagram is generated, it finds the next hop, who is my next hop to be transmitted. So, now it found that R is my next hop, right. That means the datagram or the packet has to be delivered to router first, correct. Now, this when the ARP will be executed, which IP will be mapped now? Now, your ARP will be executing for what? It will execute for the mapping the destination IP to the destination MAC, right. Now, who is the destination in this case? The router, the intermediate hop. That means, when the destination IP is now the IP of the router, and that will be mapped to the MAC of the router and will be sent back to the source, then the source will generate the frame and sending the data into it and finding the destination here. That means, this DIP is now not changed, it remains as it is in the datagram. What is changing is because in the route, when the source understands that my packet has to be routed, it looks for what? If you remember the datagram, it looks for the routing table, right. Routing table says who is my next hop, who is my next hop, and next hop meaning what? The IP address of the next hop, right. Now, this IP address will be mapped to its MAC address to know who is the actual router, because it may happen that this source is connected to multiple routers. This is router 1, this is connected to router 2. So, who is the router having this IP address for which it sorts the routing table, right. From the routing table of the source, it understands my next hop is the router having this IP address, but who is that router having this IP address and its corresponding MAC is this one. So, ARP will be executed here now to know the MAC of the router, next router. So, now it is clear that R1 is actually the router to whom the packet will be transmitted. So, now once first is your ARP request comes, Then first step is ARP request from the source to the router R1, let us say R1 is the router to whom it has to be delivered. Second step, ARP reply comes from the router 1 to source, then your packet or the datagram travels from the source to the router 1. Now this is clear. ARP request goes, finds the router, reply comes from the router is identified, then the packet is delivered to the router. So now your packet is physically or actually at this stage, correct? Agree? Now who is the sender? Now your sender is R1, and let us say this has to send to the destination network. So when it sends, what R1 does? Now the first step is R1 sends the ARP request. To whom? To all the networks in its outgoing path, right? Because from its own routing table, it finds that the next network could be here or next network could be here. Let us say it finds that this is the network where your destination is present. So when it sends the ARP, it sends the ARP to everyone, but this fellow replies back. So R1 sends the ARP request, and the second step is the destination network. Let us say this is destination network DN. This replies back with ARP reply. So now whose IP address is mapped by the ARP? The router of this network or the gateway of this network, right? So now this network IP is mapped with its own physical or MAC address. So then third step, your packet travels from R1 to the gateway, let us say this is the gateway node, fine. That means now the packet has travelled all the way from the source to the intermediate router and now to the corresponding gateway node of the network. It has come here. It is a job of the gateway to find out who is the host to whom it has to be delivered. So again what it does? The gateway sends now the gateway is the sender. This is the sender is the router, now the sender is the gateway. So what he does? He sends an request, again number 1 ARP request, number 2 ARP reply. Now when it sends the ARP request, what is the IP address? That has to be mapped, ultimately the DIP. So now DIP is the, right, because with this DIP it executes the ARP to know what is the MAC address of the receiver or the final destination, and the final destination sends the ARP request by the final destination. Third is your packet is now delivered. So now you understand which IP addresses are actually mapped for its MAC address during the journey. If it is in the same network, the IP address of the datagram itself. If it is in different network, the first mapping is for the next router, second mapping is for the gateway or any other router if possible, and finally is the destination address. This is how your IP addresses are multiple mappings of the IP address from the for the ARP takes place, and finally the host is identified by its IP address and the corresponding MAC address, and the packet is delivered. This is what is your ARP format and or how the ARP address resolution packet works, and the same remains true for RARP as well. The only difference is in RARP MAC is known and the IP is to be found. Now tell me a case when this is possible, when IP is known, I mean the MAC is known and IP has to be found out. Tell me a situation when this occurs. The principle remains same. RARP will be sent with the known MAC address and the corresponding IP will be decided by the reply.